Hi, I'm Joe James. This is my 7th video in the series on solving quadratic equations. So we're going to follow this process here to solve quadratic equations by completing the square. So we saw in the previous video what exactly a perfect square means. Here we're going to actually apply what we know about perfect squares to solve quadratic equations that can fit into this perfect square format, which is nice. First, this process applies when a is equal to 1, or in other words, the coefficient of the x squared term, there isn't a number there, it's just an implied 1. And we're going to add one additional step when we have some non-1 value for a. So first let's figure out how we do this when a is equal to 1. We're going to move c to the right. We're going to subtract c out of the left side of the equation and move it to the right side. Second step is we're going to add b over 2 quantity squared to both sides of the equation so that we can complete the square. Then we'll have a perfect square on the left. Then we're going to rewrite the equation as a binomial squared and solve for x. So let's see how that works. Here we have to find solutions for this equation or solve this equation. So again, the first step here is let's move this 18 over to the right. So we have a positive 18 right now. We're going to subtract 18 to get rid of it. So minus 18 on both sides of the equal sign. And we'll rewrite our equation like this. X squared plus 10x equals negative 18. Okay, next step is we need to add it's b over 2 quantity squared to both sides. So here, what is b? That's 10. So if b is 10, we're going to put 10 over 2 quantity squared to both sides. And let's see, that's 5 squared, which is 25, isn't it? So now we're going to add 25 to both sides. Let's do that. X squared. So we're going to add 25 plus 25 plus 25 over here on both sides of the equal sign, and we'll rewrite the equation. X squared plus 10x plus 25 equals, let's see, what's positive 25 and negative 18 gives us a positive 7, right? Okay, and now we can complete the square and factor the equation. So we know that the factors of 25 are 5 and 5. That's what we're going to use. So x plus 5 times x plus 5, or x plus 5 quantity squared is equal to 7. How did we get that? Well, we just took the square root of this 25, which is half of this b term, or the square root of the c term. So x plus 5 quantity squared equals 7. Now we can simply take the square root of both sides. X plus 5 equals square root of 7. And then we need to subtract 5 from both sides. So x equals root 7 minus 5. So that's our answer. We could multiply that out. I think root 7 is about 3, a little under 3. It's like 2.7 or something. Minus 5 will give us a negative number. So that's our solution for x. And there's only one solution for x because it's a perfect square. So as you can see here, there's x plus 5 and x plus 5. They both give us the same result. So that is our answer. Let's try another one. Here we're going to solve x squared plus 4x plus 1 equals 0 using the complete the square method. So our first step here is to get rid of this c term, which is a 1. So we have a positive 1. We're going to subtract 1 from both sides of the equal sign. And we'll rewrite our equation as x squared plus 4x equals negative 1. Now we're going to take b, which is 4, right? b is equal to 4. We're going to find b over 2 quantity squared, and we're going to add that to both sides. So that is equal to 4 over 2 quantity squared, which is 2 squared, which is 4, right? So we'll add 4 to both sides. Let's see, let's write a plus 4 here, plus 4 on this side, and a plus 4 on this side of the equal sign. We write our equation, we get x squared plus 4x plus 4 equals, let's see, we have a negative 1, so we're going to add 4 to that. We're going to get a positive 3. And then we can complete the square and write this as a perfect square. So what are we going to write? X plus what? Well, the square root of 4, which is 2. Or half of this 4, which is also 2. X plus 2 quantity squared equals 3. We're almost home free. So we've done the complete the square by adding 4 to both sides. You see that we added 4 to both sides. We can't just add 4 to one side to complete the square and not add 4 to the other side of the equation. That would screw it up. So we added 4 to both sides. We factored our equation. We know how to factor already, but it's a little bit easier because we know that this is a perfect square now. So we only had to figure out what the square root of this 4 is and write this as x plus 2 as our binomial. Now we can solve for x. So if x plus 2 quantity squared equals 3, then we take the square root of both sides. We get x plus 2 equals root 3. And if we subtract 2 from both sides, x equals root 3 minus 2. So that's our answer. X equals root 3 minus 2. And again, there's only one answer. So that's how we complete the square. If a is 1, you'll see in both of these two problems we solved so far, there's just x squared with no a there, so a is 1. Now let's look at what happens when we don't have a 1 for a. So if a is not equal to 1, then we're going to start with the same step. We'll move c to the right, but we're slipping an extra step in here. We're going to divide all terms by a. So we're going to divide the a out of the entire equation, and then we're going to follow the same last 3 steps there. So let's do a problem following this process and see how that works. Here we have 3x squared plus 18x minus 15. So again, we're going to get rid of this 15, right? That's the c. So we're going to move that to the right. We currently have a negative 15, so we're going to add 15 to both sides to get rid of it. So plus 15 on both sides of the equation. And we'll rewrite the equation 3x squared plus 18x equals 0 plus 15, that's 15. And then our second step we said was get rid of this 3. We need to get rid of that 3. So we're going to divide out the 3, but we're going to divide every term by 3. So let's divide by 3 here, here, and here. Now, I created a problem where all of these divide nice and evenly by 3 just to keep it simple, but it's not always going to work that way. So just so you can see, we can move through this practice problem a little quicker. 3 divided by 3 is just going to give us x squared. In other words, we converted the x squared coefficient to a 1 by dividing out the 3. 18 divided by 3 is going to give us 6x, so that's a plus 6x. And that equals 15 over 3, which is 5. Okay, and then our next step is to figure out what b over 2 quantity squared is. So b over 2 quantity squared is equal to 6 over 2 quantity squared. 6 over 2 is 3, and when we square that, we get 9. So let's see, we're going to add 9 to both sides, okay? Plus 9, x squared plus 6x plus 9 equals 5 plus 9, which is 14 on the right. Okay, now we can factor this. And again, we can use b over 2 or the square root of the 9. Either way, it's 3, isn't it? So x plus 3 quantity squared equals 14. So factoring was easy because we just took the square root of the 9. We know that 3 times 3 equals 9 and 3 plus 3 equals 6. So we get x plus 3 quantity squared equals 14, and then when we solve for x, again there's only one solution here, we're going to get x plus 3, take the square root first of both sides, x plus 3 equals root 14, and then when I subtract a 3 on both sides, we get x equals root 14 minus 3. So that is our answer. You can multiply that out on a calculator if you like. So that is the completing the squares method. You'll notice that completing the squares method works best when b is an even number, and of course when there is no a, right, when a is 1. Those things help. Completing the squares is very easy to do when a is 1 and b is an even number. If a is bigger than 1, or if b is an odd number, then completing the squares may not be the best choice for solving a quadratic equation. I hope this video was helpful for you. If so, please click the like button and subscribe to my channel. I'm Joe James. Thanks for watching.